Hello, everyone. In this lesson, I'm going to talk about the application of this absolute value of piecewise functions. You see, there are two pieces, right? Absolute value of x when x is greater than or equal to 0, or if x is less than 0, the absolute value of x is negative x. And its application in calculus. And of course, in this, we're not doing calculus in this course. This is a pre-calculus. We're doing the algebra part of the work in calculus. Okay, so these are the questions that are from calculus text. In fact, these questions are from calculus text. And I break them into smaller pieces, right? So we're gonna go step by step. So for absolute value of x minus 2, how do we create two pieces? Okay, how do we create two pieces? So there are two ways to do it, right? Because you can see this whole thing, right? This could be a different symbol, okay? Omega, for example. Let me find that symbol. We have that symbol right there. Okay, it's omega. If omega is greater than or equal to 0, then the absolute value of omega is omega. If the value of omega is less than 0, the absolute value of omega is negative omega. Okay? So if you have any questions about this, watch the lessons watch the previous lesson, okay? So this is the application part. This is application part. So to handle this kind of situation, we will treat x minus 2 as omega. Okay, so we treat x minus 2 as one single entity, So with that said, right, omega, when omega is x minus 2, when omega is replaced by x minus 2, so this is going to be x minus 2, this is going to be x minus 2, and this is going to be x minus 2. I hope you see that substitution, right? So the whole of x minus 2 is in the same place as omega. So this way we have two pieces. And of course, we can simplify these two pieces. Okay, how do we simplify these pieces? Be the preferred form, so we can use it in calculus. And this is what we can do. Here, the absolute value of x minus 2 is the same as x minus 2 if x minus 2 is greater than or equal to 0. And the absolute value of x minus 2 is its opposite when x minus 2 is negative. The only part we're going to do is we're going to solve this inequality. We add 2 on both sides. So we're going to have x greater than or equals to 2. And solve this inequality by adding 2 on both sides. So we are adding 2 on both sides, so we have less than 2. So finally, x minus 2, absolute value of x minus 2 is turning into that piece. This is what we want to make piecewise function. So this is a piecewise function, two pieces. For x greater than equals to 2 and for x less than 2, we have two different pieces. And it's going to be useful for your calculus work, okay, on limit and other topics. All right, so we're going to apply the same technique. On x plus 2 in absolute value. So please follow me, okay? You should be doing along my side because as you're doing this, you're not only doing calculus class, you're also doing you're not only doing pre-calculus class, you're also doing calculus class because you will encounter these questions in calculus. So now x plus 2 is going to substitute omega. You see? Substitute omega. But don't forget the parentheses here. We need parentheses. Okay? So omega will be substituted by x plus 2. And then we solve this inequality, right? And then we're almost done. We're almost done. Okay, just solve this inequality. This time we subtract 2 on both sides, right? So this is greater than equals to -2. And this is going to be less than -2. Okay, so it's done. Continue this process. Continue this process. Okay, as you can see, -2 is a number that will cause x plus 2 equals 0, right? And so before -2 and after -2, the sign of x plus 2 changes. Okay, so let me make a little note here. Note, okay, x plus 2, x plus 2 is greater than or equal to 0 if x is greater than -2. X plus 2 is less than 0 if x is less than -2, right? So basically you can see the change of sign. So x equals to x, so x plus 2 changes sign at -2. Okay, the same can be said with other examples. So if you look at the number line, there's a -2, right? There's a -2 here, right? And on this side, right, if you look at the sign of x plus 2, if you look at the sign of x plus 2, when x is less than -2 on this side, so the sign of -2 is going to be negative. At -2 is 0, right? And larger than -2, there are plus signs, right? The absolute value of positive number is the same as a number. The absolute value of 0 is the same. The absolute value of negative is opposite. So you can see these inequalities basically is where the sign changes takes place for x plus 2, and for x minus 2, the same thing. Okay, for x, for x minus 2, it's the same thing. Okay, I just didn't do it. So now if it's x minus 2, this will be positive 2, right? So it's the same reason. It's the same issue. It's the same issue. So there's a negative on this side, positive on this side. So you can see this 2 is where x minus 2 changes sign. Okay? All right, continue to finish all of it. Okay, to represent these piecewise functions. And these piecewise functions will be useful for us. Okay? One more time, I'm going to continue to take this piece to apply to x plus 4. So this time, x plus 4 is omega. So omega is replaced by x plus 4, x plus 4, x plus 4, x plus 4, And over here, don't forget there should be a parentheses and x plus 4. And then you can do this inequality right here. 6 have 4 on both sides, so x is greater than equals to -4, and this will be x less than -4. You can draw similar pictures as we did earlier, but it wouldn't be necessary because we don't need to draw every, for everyone. It's just for, understanding. And the next one, we have omega again, right? So let me bring that with us, right? Bring that with us. And this time, oh, we did this, sorry. We did this already. So now it's for x plus 6. X plus 6, right? So now omega is x plus 6. There, right? The absolute value of x plus 6 is the same as x plus 6 if x plus 6 is positive or 0. The absolute value of x plus 6 is its opposite if x plus 6 is negative. You see? And then this will become x greater than equals to -6, and this will change to x less than -6, right? All right, 2 more. Oops, 2 more. 2x minus 1. 2x minus 1 is in the place of omega. So the absolute value of 2x minus 1 is the same as 2x minus 1 if 2x minus 1 is greater than or equal to 0. The absolute value of 2x minus 1 is its opposite if 2x minus 1 is negative. So I'm as I'm doing this and I'm speaking of it, and solving this inequality, right? You would need to add 1 divided by 2. So now you're going to have x greater than or equals to half. And this other one would be x less than half. Okay. Last, number 7 in this section. Okay. And we're going to see further applications of it. Okay, so I'm going to bring the omega with us. Okay, so now omega is 3 minus 2x. So when omega equals 3 minus 2x, the absolute value of 3 minus 2x is the same as 3 minus 2x if 3 minus 2x is greater than or equal to 0. The absolute value of 3 minus 2x is its opposite if 3 minus 2x is negative. Okay? So then we're going to solve these two inequalities, right? So how do we solve this inequality? 3 minus 2x greater than equals to 0, right? You can do this. You can do 3 greater than equals to 2x. And then divide both sides by 2. So 3 over 2 is going to be greater than equals to x. So this will be replacing that. Okay. Okay, you can also say x less than or equals to 3 over 2. Okay, so I'm going to write another piece, right? So this will be x less than or equals to 3/2. And this other one, of course, will be x greater than 3/2. Okay, so this involves solving inequalities. And some of you may say, oh, how about I don't solve this inequality this way? I'm going to solve the inequality another way. Of course you can, right? Some of you may like to do the following. You're going to subtract 3 on both sides, right? If you subtract 3 on both sides, you're going to have negative 2x greater than equals to negative 3. And then you divide both sides by negative 2. When we divide both sides by a negative number, we have to switch the directions of inequality sign. So you're also going to get, we divide both sides by negative 2, you're going to get x less than or equal to 3/2. Same thing, okay? So this is the first part of applying. So let's see the application in calculus, right? Let's look at the calculation in calculus. So I got these questions for you, okay? And these are directly imported from calculus, but we're not doing the calculus part. We're doing the math part. We're doing the algebra part, okay? When you're taking your calculus class, you will know why we need it. We need these, okay? So right now we just make piecewise function, okay? We're gonna take all of these, right? We're gonna take this piece, and we're gonna take that piece, right? In case we need them, right? Let's see how we're gonna make the pieces. Okay, so this is the 2 pieces. Now what I'm gonna do is that, of course, these 2 pieces are the same thing, but just to have them available so you can see it, and it also make it easier for us to read and for you to follow. So please have your paper pencil ready and follow me. Okay. So here we have x minus 2 times absolute value of x, right? So absolute value of x is expressed in 2 pieces. So what we can do is that we will take this piece. Okay, let's go this way. Okay. We're gonna make this into 2 pieces. 2 pieces. Okay. 2 pieces like this. Because for x greater than equals to 0, right? The top piece is going to be x minus 2x, right? The absolute value of x is the same as x if x is greater than equal to 0. So when x is greater than equal to 0, the absolute value of x is replaced by x. And this other one is x minus 2 times. This was x, absolute value of x. But when x is negative, the absolute value of negative x is replaced by negative x. I hope you guys see that. Okay, I hope you guys see that. So these are the 2 pieces. These are the 2 pieces. Okay. Basically it's a substitution. Basically substitution. Or let me do it another time, right? So for x greater than equal to 0, so I'm going to put this one in. Okay, so first I'm going to put this in. I'm doing this second time, okay? Same formula. But when x is greater than equal to 0, the absolute value of x is the same as x. So this will be replaced by x. And this piece is replaced by its opposite. And then simplify. Now we can simplify it. So x minus 2x is negative x. X minus 2 times negative x, that's x plus 2x, so it's 3x. Do we need to change anything here? No, we don't need to. We don't need to. Okay. All right. Let's look at number 9. Let's look at number 9. This is also something you're going to see in calculus for sure. Okay. The absolute value of x divided by x. How do we get that? The absolute value of x divided by x. Well, we know that absolute value of x divided by x, the absolute value of x has 2 pieces, right? Has 2 pieces. So we're going to take the whole of it, that's x, right? Divided by x. So this is divided by x. So this will be divided by x, and this will be divided by x. Also notice the domain cannot be 0 anymore. So this is going to be greater than 0. Then you say, how about number 8? The number 8, we don't have such issue. The domain is all real numbers. In number 9, we have x in the denominator, therefore x cannot be 0. The domain here is x cannot be 0. All right, so you can see the process, right? You take the whole of the absolute value of x divided by x, right? We only just need one of it. And x divided by x when x is positive is just 1. X divided by x when x is negative is -1. Done, finished. You can see how we can create these piecewise functions. Now, this one. And once again, the domain is not equal to, x cannot be equal to 0 because we have x in the denominator. So how do we make this piece into piecewise functions? Right? So once again, we're going to bring this with us. Right? We put it right here. And of course, we're going to use this one. And we have 1 over absolute value of x. Right? X is not equal to 0. So if x is positive, if x is negative. The other thing we can do, okay, I'm going to show you another way. Okay, if x is positive, okay, if x is positive, the absolute value of x is the same as x. And this piece, when x is greater than 0, is going to be 1 over x is not going to be changed, right? There's no absolute value involved. But the second one, the second part, because under the circumstances x greater than 0, the absolute value of x is equal to x. So this will be replaced by x. 1 over x minus 1 over x equal to 0. Then what if x is negative? If x is negative, the absolute value of x is its opposite. So there's a negative sign there, right? That's what this branch is saying. And as a result, absolute value of x will be replaced under the circumstances by negative x. So we got 1 over x plus another 1 over x. Oops, sorry. Plus another 1 over x, right? Because there's a 2 negative sign here. 1 minus 1 over negative x as 1 over x. So in the end, we get 2 over x. Okay? So for conclusion, right? So this piece will have 2 pieces. Okay? 2 pieces. One is if x is greater than 0. right? If x is greater than 0. If x greater than 0, if x greater than 0, then this piece will be useful, then this is going to be 0. If x is negative, and we got 2 over x. So this branch, the work of this branch will be useful. Okay, so that's finished. So these are the applications you will need in your calculus class, Okay, and we have indicated the domain. All right, number 11. The domain is all real numbers. So we can utilize what we did for x plus 4. We can utilize for x plus 4. Remember what we did for x plus 4, right? So we can just continue writing it, right? This omega, these are the two pieces, right? X plus 4 is our omega. So x plus 4, negative x plus 4, right? X plus 4, x plus 4. We basically derive it all over, and we don't need this twice, right? So if x is greater than or equal to negative 4, x is less than negative 4. All right? But there's a minus 2x. There's a minus 2x, right? So this is just for x plus the absolute value of x plus 4. We need to minus 2x in each piece. Okay? Or you can do it this way. You can say, hey, it's minus 2x, right? So both are minus 2x. So minus 2x, minus 2x. And then you simplify. X plus 4 minus 2x, that's going to be 4 minus x. And over here, you're going to have a minus x minus 4, right? So it's going to be minus 3x minus 4. So that's final. That's final. All right? So you can see how we can apply these. Domain is all real numbers. Okay. All real numbers. And you can also, or you can use this this notation. Either one, you don't have to write so many different forms. We get it. Okay, we got it. Okay. Number 12. Number 12. Right? Number 12, similar, very similar. So we're gonna have x minus 3 taken care of, right? So there, omega, right? That's x minus 3. Whoops. X minus 3 in the place of omega. So x minus 3, and that turn into x greater than equals to 3, and minus x minus 3, and this is going to be x less than 3, right? And we added 2x, okay? So we're going to add 2x to it. So 2x plus, so we're going to add 2x to it. We're adding 2x, right? And then what do we get? We're almost there. Right? 2x plus x, that's 3x. 2x minus x plus 3, right? So we opened up the parentheses, and 2x minus x, that's going to be an x. That's finished. So these are the two pieces. These are the two pieces. All right. Okay, the question gets a little bit harder. The question gets a little bit harder indeed. Okay. So let's see what are we going to do about number 13. Number 13, as you can see, we have absolute value of x plus 6. On the numerator is 2 times x plus 12, right? So if you factor, you get 2 multiply x plus 6. The denominator stay the same. Okay, denominator stay the same. We have to take care of the denominator, the absolute value of x plus 6, right? X plus 6 is in the place of omega. Right, omega. There you go. And you also will get to x greater than equals to negative 6. And x is less than negative 6. And this is the second time we do this in this lesson. So now we're going to take all of these inside here. Okay, because absolute value of x plus 6 is going to be divided into the numerator. Okay, so I'm going to just copy this, remove that for the moment, because we have 2 branches, right? On these 2 branches, we got that. In the first branch, greater than equals to negative 6, the absolute value of x plus 6 is the same as x plus 6. So this absolute value sign is dropped. In the second situation, it's going to be, this one is negative parentheses, and we drop the absolute value. You can see the numerator stays, no change. Denominator, the absolute value of x plus 6 got to be, have 2 pieces. So we take care of that 2 pieces. Okay, now continue to reduce it. So x plus 6 and x plus 6 are reduced. So that's going to be positive 2. X plus 6, and there's a negative x plus 6, the 2 parentheses reduced. So this is going to be negative 2. Finished. That's it. So that's how we apply this property. Okay. Let's keep going. Number 14 is similar, but this time the absolute value is on the numerator. The absolute value is on the numerator, so we got x plus 4 is in the place of omega, right? So omega is replaced by x plus 4. Please do follow me, okay? And x plus 4 greater than equal to 0, this is going to be greater than equals to negative 4. And this is going to be less than negative 4. So now this whole thing will be replaced, right? Will be divided by 2 times x plus 8. Okay, so one more step. So I will still take these 2 branches. Okay, I'm taking these 2 branches, but that's x plus 4 alone. So all of these will have to be divided by 2x plus 4. 2x plus 8. 2x plus 8. There you go. Okay. And then simplify, reduce. How do we reduce it? 2x plus 8 can be written as 2 times x plus 4. 2 times x plus 4. Okay. 2 times x plus 4. The same is for the other 2x plus 8. It's just factor form. So dealing with these factor form, then this is going to be end up with, this is 2x plus 4. This is 2x plus 4, right? And x plus 4 reduces is going to be 2 and, no, sorry, 1/2. My bad, 1/2. Okay, because 2 is under. X plus 4 and x plus 4 will be reduced. So this is going to be negative 1/2. Okay, I hope you got that. You're going to see this at the entry. You're going to see this as entry of a calculus class. Okay, you're going to be doing this a lot. Okay, and you're going to be tested, quizzed on many times over in calculus. So not only in this course, in calculus as well. Okay. All right. This one. We got x minus 2. Okay. So take care of x minus 2. So x minus 2 is going to be in the place of omega. Right? We know that whole drill. X minus 2. X minus 2 is a whole bunch of substitution. And now x minus 2 greater than equal to 0 will become x greater than or equals to 2 or x less than 2. So that part is done. But x minus 2 is in the denominator, okay? And also, we're going to factor the numerator. We're going to factor the numerator. And the factors become x plus 1, x minus 2. And the absolute value of x minus 2 comes with us. Now we have absolute value x minus 2 in these two cases. I'm going to bring this over, right? And these two pieces I'm going to remove. Just do this. Okay, this is probably easier. Well, x greater than equals to the negative, well, x greater than equals to 2. Oh, wait a minute. I need to indicate the domain. Yes, indicating the domain. I'm so sorry. Here, okay, domain x cannot be -6. Okay, so this should be greater than -6, greater than -6, greater than, and this one is greater than or equal to -6. This one is correct. But once we move to this part, I apologize, okay, but I'm glad I taught it before the recording is over. So because we have to be aware of the domain. That's why these questions ask for domains. So this equal has to be removed. And for this other case, the domain in this case, in the next case, is x cannot be -4. So this part has to be greater than -4. This part has to be greater than -4. Okay, and this part doesn't need to be changed. Okay, but when we work these out, we need to have greater than or less than, no equal to -4, because that will make denominator equal to 0 undefined. So the same thing is about 15. Okay, I apologize for that. So let me just show you one more time. This is number 13. Domain is x not equal to -6. I was trying to rush things through, so I forgot about the domain. Sorry about that. But now we caught it. So x is greater than -6, less than -6, not including equal. And for number 14, the same thing, because we cannot make the denominator cannot be 0. Now for number 15, right, we cannot have equal to 2. And the domain, okay, the denominator cannot be 0, so x cannot be positive 2. It's okay to keep it equal to 2 here because it's just absolute value x minus 2. But when we bring this to this expression, we have to drop the equal sign. Okay, so when x greater than or equal, when x greater than 2, this is the same as the absolute value of x minus 2 is the same as x minus 2. In the second case, we will need a negative sign because of that rule. All right, so finishing this up, right? Now we can reduce. Before we drop the absolute value sign, we cannot reduce it. So now x minus 2 will reduce, so the top will only be left with x plus 1. When x less than 2 and x minus 2 will reduce again. This time we'll have negative of x plus 1. Of course, you can open up the parentheses if you want. Okay, so that's about domain, which is essential, and you also need that for calculus to be aware of that. Okay, 2 more to go. Number 16. Number 16, seemingly we don't see anything that's, we have an absolute value of 2x to the power 3 minus x squared, right? And of course, we need to work out the domain. So one of the things we can do inside the absolute value, it looks like we can factor out the x squared. Okay, if we factored out the x squared, we're going to have x squared multiply 2x minus 1. Okay, x squared, well, now we know that domain, right? X cannot be 0. X cannot be 0 for sure. And x cannot be 1/2. Okay? Both must be satisfied. And it cannot be 0, cannot be 1/2, because 2x minus 1 would be 0 if x is 1/2. We cannot be 0 either. We found the domain, but in this domain, x squared is always positive. So it can be pulled out. It can be pulled out the absolute value because absolute value of positive is positive. So now in the denominator, we got 2x minus 1. On the top is 2x minus 1. Be careful. We cannot reduce these 2x minus 1, because one has absolute value and the other one does not. Okay, so what are we going to do with 2x minus 1 in absolute value? Well, the same trick that we did previously. So omega now is 2x minus 1. 2x minus 1. So this piece, omega is replaced by 2x minus 1, 2x minus 1, 2x minus 1. Solving this inequality, this is going to be, we've done this before, x greater than equals to 1/2, right? And the other one, we will have x less than 1/2. We got this piece taken care of. We got this piece taken care of, right? And now we're not done. We're not done right? So let's continue to finish this, right? Obviously, we're gonna have two branches. We're gonna have two branches, right? We have these two branches. And what I'm gonna do this. Okay, the whole thing. The whole thing, because I have this piece. 2x minus 1 in absolute value, right? Well, x is greater than equals to half. So this condition would apply because in that case, absolute value 2x minus 1 is the same as 2x minus 1. So this absolute value sign can be dropped. And this absolute value sign can be dropped when x is less than half. But we need to change this to be greater than because of domain concern, okay? Be aware, in this case, we don't need to drop the equal. But in this case, we must drop the equal because of domain, all right? And now, when x less than half, absolute value 2x minus 1 is the opposite of 2x minus 1 in parentheses. So now we can drop this to replace by parentheses, and there's a negative sign. So now we can reduce the 2x minus 1. Okay, so one more step, 2x minus 1. Take away the 2x minus 1. 2x minus 1, take away the 2x minus 1. And we're finished. If you want to look at prettier, you can bring this negative sign in front of it. That's it. That's the end of it. Right? You can see, excuse me, you can see these expressions comes in a bit more complex. Okay, a bit more complex. And you have to, we have to use our factoring technique. How to use our factoring technique. All right. Next, we have a very interesting. We have two absolute values. Okay. In this case, in the setting, well, you are going to see this question in your calculus class, but the question itself, okay, is about in the neighborhood of 2 plus x. Okay, so here we're going to have a little discussion. Here because but we're going to make some assumptions. Suppose, okay, x is negative. And x is near -2. Why do we put this assumption? The question you are going to be dealing with in calculus is that situation. If it's not, you can do something similar. So the reason we say x is negative, right? So since we assume x is negative, because if x is near -2, we can assume x is negative. If we know x is negative, then the absolute value of x, when x is negative, would be equals to -x, right? But what do we do here? We do need to tell the reader the circumstances we're working this. And so we're gonna assume that, well, we have this omega. Omega is 2 plus x. 2 plus x, right? 2 plus x, the same drill. And x is greater than or equals to -2. And x is less than -2. Domain, okay, be aware. Domain is x cannot be equals to -2. So x is in the neighborhood, in a small neighborhood of -2, but negative. Okay, so under the circumstances, we got this. We got for 2 plus x, right? For 2 plus x. So let's finish the question. Under the circumstance, we suppose x is negative, okay? And then we're going to have these two pieces. We're going to have these two pieces, okay? Which are here. I need to put this one over here, this one over here. So under the circumstances, okay, so I'm going to make that clear, okay? The absolute value of 2 plus x when x is less than -2, that's going to be negative. That's going to be negative 2 plus x inside parentheses. And when x is greater than, this time we have to remove the equal because the domain concern. So this absolute value will be the same. All right. And because the assumption of x is negative, so this is going to be absolute value of x will be replaced by negative x. Replaced by negative x. Okay. So afterwards, okay, this will be 1 plus x, and this will be 1 plus x. So be careful, this is under the circumstances of that calculus question we took it out of, right? Then you say, well, what if it's in the neighborhood of 0? Well, if in the neighborhood of 0, and we can assume x is not equals -2, so the denominator would not be of a concern. Okay, so for now, take this question because we take it out of the context of calculus. So, and this version is going to be the useful version for you. Okay, this version is going to be, because for this question, there could be two different versions. Depending on, is in the neighborhood of -2 or in the neighborhood of 0. And in the calculus context, it is in the neighborhood of -2. So this version is the version you are going to, this is the version I want you to understand so you can deal with that calculus question. Okay, so let's just recap a little bit, make sure I don't miss anything, don't do anything wrong, so we can correct it. The domain issue is being taken care of, okay? The domain issue arises when we have a denominator, like in these cases. And there's no domain issue because in these cases, the domain is just all real numbers, right? These domains is all real numbers, so we don't have any, we have no concern about it. And in, yeah, for these other cases, right, you can see we will have domain issue. The domain is x not equal to 0, and we did this right, greater than equal 0, greater 0, less than 0. And yeah, we got these right. The domain is considered, right? All right, so I think I have double checked. I have corrected all the mistakes I made. I hope those mistakes will be a good lesson for you to learn as well. Be aware of the domain. Be aware of the domain. And in your calculus class, you will be working around these kind of questions. So we're just doing the algebra part. Okay, thank you for watching.